Good morning, students. Yes, physics chapter 4, motion in plane, continue. Yes, in last lecture we have discussed about position, displacement, velocity and acceleration. Yes, we have also discussed in chapter number 3. Now on same topic we will revise, okay, but in terms of vector. Yes, from chapter number 3, motion in a straight line, what is important question? Kinematic equations for uniformly accelerated motion. And yes, you know motion, equations of motion. You know equations of motion. Similar equations you have to prove in terms of vectors for vector quantity. Okay. So see, what is title? What is title? Motion in a plane with constant acceleration. Motion in a plane with constant acceleration means you have to prove same equations. Okay. But when object moves in a plane. Okay, so first of all we are assuming, okay, let a particle is moving, a particle is moving in xy plane, with constant acceleration, a. And yes, as it is constant acceleration, I can write a is equal to it is axi plus ay, because it is moving in xy. Clear about this? Okay, so a particle is moving in xy plane with constant acceleration. Now I am assuming situation, let similarly at time t is equal to 0, its position of particle is r0, position vector r0, okay, and its velocity is v0. Clear about this? At time t is equal to 0, position of particle is r0, it is its position vector r0, okay, its initial velocity is v0. At time t is equal to t, let its position is r and its velocity is. Clear about this? Clear about this? Okay, so yes, this first thing you have to assume. Okay, you let at time t is equal to 0, position r0, velocity v0. At time t is equal to t, position r and velocity v. And yes, we know that we can write this position vector in terms of components. Also this velocity in terms of components. How to write this? I can write this r0 is equal to, it is x0, y0. Clear about this? I can write this r is equal to x, y. Clear about this? Okay, now what is meaning of x0 and y0? x0 and y0 are x and y components of initial position. So we can say x0 means x component of initial position. X means x component of final position. Y0 means y component of initial position. Y component of final position. Similarly, I can also write this v0 in terms of components like this. It is v0x and v0y. Okay, and here this v as vx and vy. Now what is v0x? X component of initial velocity. v0y, y component of initial velocity. vx, x component of final velocity. vy, y component of final velocity. So yes, you have to remember this each and every point. Acceleration a is equal to axi plus ayj. What is ax? X component of acceleration, y component of acceleration. Initial position vector r0, its x component, its y component. Final position, its x component, y component. Initial velocity, x component, y component. Final velocity, x component and y component. Clear about this? About this each and every term? Okay. Now, how to obtain equations? See, first equation, it is simple. We know from chapter number 3, okay, if object is moving with constant acceleration, average acceleration is equal to instantaneous acceleration. Average acceleration is equal to instantaneous acceleration. So I will use definition of acceleration. See, that is A is equal to delta V upon delta t. Yes or no? A is equal to delta V upon delta t. So yes, I can write this. A is equal to delta V, change in velocity, final velocity minus initial velocity. What is final velocity? Here it is V. So it is final velocity V minus initial velocity, means here it is V0, divided by delta t time, here it is t minus t. See, acceleration is vector quantity, so you have to put arrow on its symbol. Velocity is also vector quantity, while t time is scalar quantity. Okay, so now if you multiply t this side, you will get at is equal to v minus v0. Okay, so now if you make v as subject, then you will get v is equal to v0 plus at. V is equal to v0 plus at. It is first equation. Clear about this? Okay. Now we have to find its components. See how to find its components. Here its components. V, final velocity. What is its x component? X component. Okay, chalo. What is x component of this final velocity? Here it is Vx is equal to initial velocity is v0. What is its x component? V0x. It is V0x plus a acceleration a. What is its x component? Here it is ax. And t, it is scalar quantity, means it does not have any components. Clear about this? How to write this equation? Clear about this? Vx is equal to v0x plus axt. Now, how to write its y component? Its y component. See again, v. What is its y component? Vy. Its y component is Vy. V0. Its y component is V0y. A, acceleration, its y component is ay. So here it is ay, and yes, here it is t. So yes, you have to remember these two equations also. Clear about this? Okay. Now yes, one equation is true. V is equal to V0 plus at. Now for second equation. Yes, we know definition of average velocity. Average velocity means displacement upon time. So displacement is equal to average velocity into time. Yes or no? Displacement is equal to average velocity into time. Okay. Now displacement means final position minus initial position. Final position is r, initial position is r0. Then how to write displacement? R minus r0. Yes, it is r minus r0 is equal to average velocity, means if you remember from chapter number 3, we can write v0 plus v divided by 2, and yes, it is average velocity, and here it is time t. Clear about this? Okay, now see, r minus r0 is equal to, here it is, v0 plus v, put value of v is equal to v0 plus a, okay, divided by this 2, and yes, here it is t. Clear about this? Okay, so I can write this as r minus r0 is equal to, now see how to simplify this. v0 plus v0, 2v0 divided by 2 means v0 and into t, so you will get v0t. Again, v0 plus v0, 2v0 divided by 2 means v0 into t, so v0 t plus 80 into t, 80 square divided by 2 means it is half 80 square, means it is half 80 square. Clear about this? Now if you make this r as subject, then r is equal to r0 plus v0 t plus half 80 square, plus half 80 square. So yes, it is your second equation. It is your second equation. Okay, and now how to write its components? See, its x component. Its x component. Okay, see how to write x component. R final position. R final position. What is its x component? X is equal to r0 initial position. Its x component is x0. Yes, it is x0 plus v0 initial velocity. Its x component, it is v0x. T, it is scalar quantity. Okay, t is scalar quantity plus half a acceleration's x component. It is ax. And again time is scalar quantity, so it is ax t square. Remember this equation we have proved in chapter number 3. X is equal to x0 plus v0 t plus half at square, plus half at square. Clear about this? Now how to write y component? Yes, you can easily write its y component. Y component y is equal to y0 plus v0 yt plus half ay t square. Okay, so yes, here students, you know about these two equations. Okay, you have to remember these four equations also. See, these two are called x and y components of velocity at time t. These two are called x and y components of position. X and y component of position at time t is equal to t. And yes, if you know these equations, each and every term, then it will be easy to understand projectile motion. It will be easy to understand projectile motion. In projectile motion, we will start our theory with these four equations. So yes, take care about this theory. Is easy, but yes, you have to remember in terms of components. Okay, so it is motion in plane with constant acceleration. Now we will see some examples. Okay, now we will see one example. See, example 4.4. Position vector is given 3ti plus 2b square j plus 5k. You have to find what is velocity at time t and acceleration at time t. Second question is find magnitude and direction of velocity at time t is equal to 1 second. See students, it is easy. Okay, here first of all, position vector r is equal to 3ti caret plus 2t square j caret plus 5k caret. We know how to find velocity. Yes, velocity v is equal to, it is dr upon dt. Differentiation of position with respect to time. So yes, you know differentiation. What is differentiation of 3t? What is differentiation of 3t? It is only 3. Yes, you have to just write I caret. Okay. Plus, what is differentiation of 2b square? Yes, it is 4t. Here it is j caret. Simple. Plus k, plus 5k caret. 5 constant. No term having t. So yes, its differentiation is 0. Clear about this? Okay, so yes, it is simple. If it is given position vector, how to find velocity? You have to differentiate with respect to time. Okay, now it is equation of velocity. Yes, okay. Now how to find acceleration? We know that acceleration is equal to dv upon dt. So differentiation of this equation of velocity with respect to time. 3i constant, so its differentiation 0. Plus 4tj, 4t its differentiation is 4 and j caret as it is. And yes, here it is the 0. Okay, so yes, what is velocity? V is equal to 3i plus 4tj. What is acceleration? 4j. So yes, here you can say acceleration A is equal to 4j, means constant. So yes, we can say it is uniform accelerated motion. Uniform accelerated motion, because here acceleration is constant. Okay. Now you have to find magnitude and direction of Vt. I will write equation of V again. V is equal to 3I plus 4tj. Now add time t is equal to 1 second. So V1 is equal to, it is 3I plus, you have to put value of t1, it is j. So yes, here it is 3I plus 4j. Now you know how to find its magnitude and direction. You know how to find its magnitude and direction. Yes, first of all we will find its magnitude. V1 is equal to under root 3 square plus 4 square. Clear? What is your answer? Write your answer in comment box. How to find its direction? Theta is equal to, it is tan inverse 4 by 3. Y component upon x component. Clear about this? So yes, it is one simple question based on position, velocity and acceleration. You know differentiation, how to find differentiation? You can easily find velocity and acceleration. What is new? Yes, you have to put value, it will be a vector, you have to find its magnitude and direction. Clear about this? Okay, so yes, now we will see another one example. Okay. Now next example, example 4.5. A particle starts from origin at time t is equal to 0 with a velocity 5I meter per second and moves in xy plane under constant acceleration of 3I plus 2j meter per second square. Question A. What is y coordinate of particle at the instant when its x coordinate is 84 meter? Question B. What is the speed of the particle at this time? Now see, first of all we will understand data. Okay, what is given? A particle starts from origin at time t is equal to 0 with a velocity 5I meter per second. Starts from origin. Origin means initial position. Initial position. R0 is equal to, I can write 0, 0. Clear about this? Initial position, it is starting from origin. At time t is equal to 0 with velocity 5I meter per second means it is called initial velocity. So initial velocity V0 is equal to, it is 5I cap. Okay, next, and moves in xy plane under constant acceleration. So yes, it is acceleration. It is acceleration. A is equal to, what is A? It is 3I plus 2j. Okay. Now first question is, what is y coordinate of particle at the instant its x coordinate is 84? Means first question is like this. You are given x coordinate, that is 84 meter. Okay. You have to find what is y coordinate at the same time. Clear about this? So now we will find this with the help of such equations. See now what you are given. Initial position R0. Initial velocity V0, acceleration A. You have to find y component and you are given x component. So obviously, you have to use only one equation. You have to use only one equation in which you have position, velocity and acceleration. And that equation is, yes, here it is. R is equal to R0 plus V0t plus half 80 square plus half 80 square. Yes, you have to use this equation. Okay. Now put value. See, R is equal to R0, initial position starting from origin. Yes, here it is 0, 0 plus V0. What is value of V0? It is 5I. So yes, it is 5I caret into T plus half. What is value of A? A is 3I plus 2j. 3I plus 2j and here it is t square. Clear about this? Okay. Now see, this R0 is 0, 0. If you add any quantity with 0, 0. Okay. For example, 3, 4 plus 0, 0. Your answer will be, it is 3, 4. Yes or no? Yes it is. Yes it is. Okay. So here, if it is 0, 0, you add with this any quantity, it will remain the same. So I can write this as R is equal to, I will not write this, okay, 5it, so I can write this 5t I carry plus, now see next step, 1 by 2 into 3i into t square, again 1 by 2 into 3i into t square, so I can write this as 3 by 2 t square I carry, any doubt, okay, plus 1 by 2 into 2j t square, so this 2 and 2 cut, then it is only t square j. Clear about this? Okay. Now R is equal to 5t I caret plus 3 by 2 t square I caret. So I will take I caret common. So it is 5t plus 3 by 2 t square I caret plus t square j caret. Okay. Now see, hello, you have to compare this equation with your standard equation. How to represent any position vector? How to represent any position vector? Yes, we have discussed in last lecture. R is equal to xi plus yj. Yes or no? R is equal to xi plus yj. I caret. Then yes, it is obvious. Let us put x component. Here it is I caret, means this whole term is x component. Then how to write? Okay, here x is equal to 5t plus 3 by 2 t square. 5t plus 3 by 2 t square. What you have to find? Y component. Compare y component. Y is equal to, here it is t square. Now to find y component, first of all you have to find what is value of t. You will get value of t from this equation. Put each and every value. See what is x. X is equal to 84 is equal to 5t plus 3 by 2 t square. 3 by 2 t square. Clear about this? Okay. Now here, if you multiply to this side, then it is 168. To multiply this, so it is 20 plus here it is 3t square. Clear about this? How to simplify this term? You know. Now 3t square plus 10t minus 168 is equal to 0. Yes, it is quadratic equation. It is quadratic equation. Yes, you have two methods. First method, 168 into 3, then whatever your answer, that answer you have to find in this addition or subtraction of this. Yes, you can find with the help of this method. Okay, but if it is difficult to take their components, then yes, you can use this method that we have already discussed. See, here it is. T is equal to, you know equation, x is equal to minus b plus or minus under root b square minus 4ac upon 2a. Yes or no? Yes. Here it is value of a. Here it is value of a. What is value of b? It is 10. And here it is value of c. Then now, how to find this value of t? See, t is equal to minus b means 10 plus or minus under root b square means 10 square. Minus 4. What is value of a? Here it is 3. What is value of c? It is minus 168. Divided by, here it is divided by 2a, means 2 into 3, means 2 into 3. Clear about this? Okay? Okay. So now t is equal to, here it is minus 10 plus or minus under root. 10 square means 100. This minus will become plus. If you multiply 4 into 3 into 168, you will get 2016. You will get 2016. Divided by, here it is 6. Divided by, here it is 6. Clear about this? Okay. So now how to simplify this? T is equal to minus 10. Yes, it is minus 10. Plus or minus 100 plus 2016. It is, yes, under root 2166. And if you find its square root, you will get your answer 46. You will get your answer 46. Divided by, here it is 6. Okay? Okay? Now, again, we have two cases. T is equal to minus 10 minus 46 divided by 6. If you simplify this, you will get t negative. You will get t negative. And yes, it is not possible. It is not possible. Time is negative. It is not possible. Clear? So yes, which case you have to consider? T is equal to minus 10 plus 46. divided by 6. 46 minus 10. So yes, t is equal to it is 36 divided by 6. So t is equal to it is 6 seconds. T is equal to it is 6 seconds. Means, what is conclusion of this? X component is 84 when time t is equal to 6 seconds. X component is 84 when time t is equal to 6 seconds. Now how to find its y component? Now how to find its y component? See, what is y component? Y is equal to t square. Y is equal to t square. Means here it is 6 square. Then y is equal to 36 meter. Y is equal to it is 36 meter. Clear about this? Clear about this? Okay, so yes, if you are given x component, then how to find y component? If you are given x, then how to find y? Okay, now yes, what is second question? Second question is, what is the speed of particle at this time? What is speed at this time? Hello students, what is speed? Speed means magnitude of velocity. Speed means magnitude of velocity. First of all, you have to find velocity. Velocity you have to find with the help of, yes, position vector. Here it is position vector. See, here it is position vector. R is equal to, it is 5t plus 3 by 2 t square I caret plus t square j caret. Okay, so yes, it is position vector. If you differentiate this position with respect to time, you will get velocity. V is equal to dr upon dt is equal to, what is differentiation of 5t? Yes, it is 5. Yes, it is 5. Plus, what is differentiation of 3 by 2 t square? 3 by 2 as it is. And differentiation of t square means it is 2t. Okay, yes, here it is I caret. Plus, differentiation of t square, it is 2t. 2t j caret. Okay, so this 2 cut, this 2 cut. Okay, so what is equation of velocity? V is equal to, it is 5 plus 3t I caret plus 2t j caret. Now you have to find velocity at this time. At this time means at time t is equal to 6. At time t is equal to 6. So put value of time v6 is equal to 5 plus 3 into 6 I caret plus 2 into 6 j caret. So v6 is equal to, okay, 6 into 3, 18. 18 plus 5 is 23. 6 into 3, 18. 18 plus 5 is 23. So yes, it is 23 I caret. Plus 2 into 6, it is 12. So yes, it is 12 j caret. Hello students, it is velocity. It is velocity. You have to find speed. Speed means you have to find its magnitude. So v6 is equal to, yes, it is simple, under root 23 square plus 12 square. Whatever you will get, it is your speed. Okay, yes, you have to write what is value of speed in comment box. Clear about this? Okay, now you know this question. Yes, it is question. First of all, you have to use this equation, then compare max, then yes, again it is physics. Okay, now one similar question you have to solve as your homework. See, exercise 4.21. Okay, particle starts from origin at time t is equal to 0 with velocity 10 j caret meter per second. 10 j caret meter per second. With constant acceleration in xy plane 8I plus 2j caret. When x coordinate is 16 meter, find what is time. Okay, what is y coordinate at the same time, and find speed at this time. So yes, it is similar question. So initial velocity, acceleration, and it is x coordinate. Just values are changed. But it is same question. Clear about this? All the best.